Okay, now we're going to start looking at, this is a lot of theory today, and a lot of, I don't want you memorizing stuff, I want you to understand this stuff. Now, we are talking about two types of exponential functions today. We're talking about, first of all, exponential growth. So if you ever see something like this, where it's going, 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 oh, make sure I'm not actually on the line, I'm just above it. So it's just going, 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 and then it goes like this. Maybe a little nicer than that. That is an exponential growth. Also said it is growing exponentially. Now, the other type is when you have exponential decay. And exponential decay would look something like this. Okay, so it is basically always going down by a certain rate, right? And this one is always going up by a certain rate. Now, if you remember last year, remember how we talked about St. Matthew's Island? And we talked about the reindeer, and this was the graph of the reindeer. Now, remember that exponential growth, where am I, is mathematically will always go this way, but actually in real life, it always gets to a peak and then it crashes. Okay, that's called when the bubble bursts. You'll look at any recession. Just before the recession is probably the richest the country was doing right before. Okay, it's not like yeah, things are going bad, going bad, going bad, then we have a recession. Okay, a lot of people had a lot of money right before the recession, and then it crashed. Okay, the the saying that the hardest part about being on top is staying there, because it's hard to keep that without it crashing. I mean, if you're a movie star, if you're a rock star, it does that, and then it's a crash. Okay, and then you can rebuild, and the whole thing of it is try not to get that up too high. And you'll see that movie stars, that kind of thing, they'll make sure that they don't get it up there. Okay, and if you do some thinking about movie stars that have always kept solid throughout, they don't get where the money's getting out of control. They're buying all the drugs, they're doing, they're going out every night, drinking, the whole thing. And then bang, it crashed. Their whole career crashes, right? So it's to try to keep it level. That is the goal. Because if it was a virus, okay, go, 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 and it could either kill the host, or maybe they found a cure, so they give you that injection and it just kills it. Okay, so the virus, but you'll see the virus right before it kills its host, it will be at the most it's ever been, and then it's totally gone because of the host. Okay, so what should the virus do? They should all talk to each other and go, we could live for years and years and years if we just calm down here. But they're like, no, they're greedy, right? And they just keep going and going until they kill the host, right? See, viruses aren't very smart. Now, when we talk about something decaying, okay, say I had $1 billion and it halved every year, okay, would I ever run out of money? No. Okay, so weird things are going on even when it comes to mathematical theory and mathematical life. Like, it will never ever go to zero, but come on, really, after a while, when I have 1 penny and that's cut in half, then that's cut in half, then that's cut in half, then that's cut in half, I'm not going to have a lot of money. Okay, like, when you had $1 billion and you've lost it all, and you have 1/100th of a cent, it's not going to make you feel better when someone goes, well, at least you're not totally broke. Okay, so this stuff's in theory that money does basically get to zero, but when you're doing the math, you'll see it never totally hits zero because you can keep halving something forever. You will still have something. Okay? And it's weird that, well, you think about those, put two reindeer on an island. Well, see, like, didn't we have zero reindeer at one time? Right? But then how does zero reindeer become two reindeer? So there's a lot of weird stuff when you start thinking about, like, how do you even do this exponential growth? Like, how did you get one little virus? Like, where did that one little virus come from? It just appeared one day, and then now it's a virus in someone's body. And so everything that actually starts exponentially, the question is, where does it just appear? Like, I get two reindeer come to an island, but there must have been zero reindeer at one time. Okay, but then the question becomes, how do you get two reindeer if there was zero reindeer? Okay? Might be more of a faith question than anything. Now, when we look at these two, it is now we're going to be talking about the unknown is actually going to be the x. Okay? But let's talk about these two functions, and let's look at the two graphs, y equals 2 of x and y equals 1/2 x. So if you got out your calculator, okay, so get those in there. So we had y equals 2 to the exponent x, and we have y equals, in brackets, I'm going to put 1/2 to the exponent x. Now, just so you know which is which, let's make this one the bold one so I don't, and hit zoom 6. Okay, so can you kind of draw those graphs quick on that? Okay, so let's just label them. This one was y equals 1/2 to the x, and the other one's y equals. Now, does that make sense that those graphs would fit with those? See, the one is halving every single time. And you can see it halves, halves, halves. Now, where do they go through the y-axis? Two or one? Just hit trace 0. Why are they going through 1? Can anybody give me a mathematical explanation why they're going through 1? Yep, I just need it a bit clearer than that. Yep. Exactly. Remember when the exponent equals 0? They always equal 1, right? Like if you have, remember when I said if you had cow to the 0, it equals 1, right? So 1/2 to the 0 equals 1, 1/millionth to the 0 equals 1, 50 to the x equals 1, or 50 to the 0. Anything to the 0 equals 1, right? Now, what else do we see? What would you say these two graphs are to each other? Yep. They are symmetrical, yeah. But let's use some of the language we learned in the last unit. Yes? Okay. Does that, everyone see that? So these are reflections on y-axis. Now the big question is why? Why would you know that without even graphing them? Sort of. What is a reflection on the y-axis? X switches sides. X turns to negative x, correct? Is that a reflection on the y-axis? Well, let's try that, okay? If y equals 2 to the x, and I want to do a reflection on the y-axis, we're saying, well, we learned last unit, x goes to negative x. If you're going to do a reflection on the y, do that. So y equals 2 to the negative x now. What does that equal? Now this is 2 over 1 to the x, right? Negative x, I should say. So this would be 1/2 to the x. So you can see why, mathematically, I can even prove they are reflections on the y-axis. Does that make sense? Okay. The last unit, we're still going to use. Okay. Now, if you don't understand the last unit, this stuff is still going to be confusing. Okay. If today's your first day in this class, you're going to wonder, what? How did they know that? Okay. Because we did lots of it, and the rules do not change. It's not going to be, okay, last unit, x, if you're placed with negative x, that's a reflection on the y-axis, but it's not going to work anymore for the rest of the year, okay? So just know that. I'm not going to throw anything like that at you. Now, another thing is, remember how it is going along here? But, so I'll use this here. It is going here, 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 but it never quite touches, does it? It's going right here, and it never quite touches. So what's this thing called? I know it's the x-axis, but don't call it that. What is this called? This is an asymptote. What type of asymptote? A horizontal asymptote. At? What's the equation of it? What is the synonym for the x-axis? Y equals 0. Okay, that's the actual equation. So the asymptote is the line, this is given curve, but gets closer and closer to 0. So for us, it is going to be when y equals 0, aka the x-axis. Remember, those are synonyms, right? Anytime I say y equals 0, that means the x-axis. If I say what to be the y-axis? X equals 0, okay? Now let's talk about these two. What is the domain of x? Is it going to go forever in both directions? Yep. So x in the reals. How about the domain of 1/2 the x? Same thing. Okay, what about the range? What would be the range? No. It has to be greater than 0. We're not going to put greater or equal to, because it will never be equal to 0. What's the x-intercept? None. Okay. We can't contradict the last one. What's the y-intercept? 1. What's the equation of the asymptote? Y equals 0, right? Okay. So when it's 2 to the x, it is called a growth function. When it's 1/2 to the x, it is called a decay function. Now, when it is y equals b to the x, can anybody tell me what b has to be a growth? Okay, I want you to think about it. What would be the restrictions on b for it has to be growth greater than 1. So b has to be greater than 1. It could be equal to 1 though, right? No, it can't. What happens if you take 1 and multiply it to the 80th power? Yeah, some people think it's 80, okay? But 1 times 1 times 1 times 1 times 1 times 1, you probably get the point. I don't have to do it 80 times, I hope. It's going to be 1. So for anything to grow, it's got to be just a bit bigger than 1, or obviously greater than that. What would be the equation for B if it had to be decaying? No, it's not. It has to be, B would have to be less than 1, but greater than 0. Now, don't get into being negatives. Negatives don't actually make things, I mean, when you minus things, it goes down, but when you multiply by negative 2, it's not decreasing it, okay? It's not like you're going to have $1 billion and then someone's going to come multiply it by negative 2, and that's how much you have now. How can you have negative $2 billion? Well, I guess you could say, okay, but that wasn't a garage, that just happened, bang, okay? Okay, now let's go over to this. Now, y equals 3 to the x. I'm just going to put this one in, and let's kind of put it like that. Say that's y equals 3 to the x. I want you to take a guess. You all have pencils. Where would y equals 10 to the x? What do you think it would look like? Y equals 10 to the x. Okay. Now, would 10 to the x rise faster? So, and what would be its y-intercept? Shouldn't it be at 10? Doesn't make sense. It's like way bigger. Why would it go through 1? Because if I put it x is 0, it's still going through 1. So it actually does the same kind of not very good there, and then it gets its momentum. Not that good. It doesn't actually go backwards, okay? So y equals 10 to the x. Okay, so we did this one in red. Do this one in black. Now, let's go right to this one. Where would you expect y equals 1 over 10 to the x be? The other side. So would it be steeper than 1/3 to the x? Why? Because it's a reflection. Also, when you take something and you're multiplying it by 1/10, it gets smaller faster. So there's two ways to think about it. The first one is it better be a reflection of this one, or you did something wrong. And this one better be a reflection of this one, or you did something wrong. I'm taping right now, so I can't. Okay. Now, when we're talking about some rules now, we already talked about B. If B is greater than 1, the curve rises more sharply as B increases. If B is between 0 and 1, the fraction we were talking about, then it falls more sharply as B decreases. So smaller B as it falls. Now, The question would be, where do you think y equals 5 to the x would be? And I hope we're assuming that it would go right here, right? Oops, let's put it down there. Does that make sense? Okay, so where would you expect point 2 of the x to be? Why is it a reflection? Point 2 is not a reflection of 5, is it? What's point 2? 1/5. So y equals 1/5 to the x. Okay, well then I would expect that to go through here, right? Hopefully you can read that, because I can't. Uh-oh. I'll have to de-wonky it. Come on, baby. Okay, so let's verify using graphic calculator. Trust me, it works. What is the y-intercept? We're doing E right now. What's the y-intercept? X-intercept. Sorry, x-intercept. What's the x-intercept? So none. Y-intercept, 1. Domain. X in the reals. Range. Y is greater than 0. State the equation of the horizontal asymptote. Y equals 0. Okay. The plot thickens. Now we're going to put an A in front. So let's get y equals 3 to the x down again. That's this one. Let's get it down. It's called our reference, right? Let's just call that y equals 3 to the x. Now let's go right to this one. Y equals 5, 3 to the x. Okay? Someone needs to tell me exactly where that would go. And there's a catch. I need to know why. No calculators, don't cheat. Okay? Someone's got to know. Put up your hand. Who does that 5 belong to? Yep. Why? Why are you doing 5 times? Okay, so if you put in 0 there for the x, that's 5 times 1, right? So at 0, it should go through. Okay, so that is the substitution way to explain it. What is a mathematical way to explain why it does that? Is that a hand up? No. Who does that 5 belong to? The x or the y? Okay, so could we rewrite this as 1/5 y equals 3 to the x? So it was y equals 3 to the x. It's now 1/5 y equals 3 to the x. What does that mean? It's what kind of stretch? A vertical stretch by 5 about x-axis. So I'm going to take it and I'm going to stretch it. So if I stretched it, I'm going to multiply every y by 5, right? So for sure, the y-intercept would have to get 2, 3, 4, 5. The y-intercept would have to get multiplied by 5, right? So that's going to look something more like this. So y equals 5 times 3 to the x. And remember, that x is not talking to the 5. It belongs with the y. Okay, so now where would you expect 2 times 3 to the x to go through? Hope we'd expect it to go through 2. Okay, let's go down to the chart here. So in y equals 3 to the x, what's the value of a? And we're talking about this equation here, right? Up here. What's the value of a? 1. Value of b? 3. And the y-intercept? 1. Next one, value of a? 2. Value of b? 3. Y-intercept? 2. Next one, value of a? 5. B is 3. What do you think the y-intercept would be? 5. So what effect does a have on it? Well, that is a vertical stretch by a, which also equals the y-intercept. Okay, and this just repeats that over and over again. Okay, so let's just complete this fast. We have y equals a b to the x. What's the y-intercept? A. What is the x-intercept? None. What's the x-axis is the? Good. Horizontal asymptote. If you always forget the spelling, there's a t-shirt on the side. You can, don't put 2 s's in it. What's the domain? X in the reals. Range. Y is greater than 0. Okay? When b is greater than 1, this represents a growth. When what? The function represents a decay. B is less than 1 or greater than 0, right? If the value of b affects the steepness of the graph, when b is greater than 0, the curve rises sharply as b decreases. When it is between 0 and 1, the curve falls as b decreases. Okay, and this stuff, it's all bad. We're not talking about expansions and compressions. It's not in the curriculum, as long as you know it as stretches. Okay, here's the original, here's the after. I want you to take 25 seconds and tell me how the first or the second graph, what happened to it? There's the first one. What happened to it? AKA the entire last unit. You need to know for this one. Nothing new. Okay, so there's 3 things I'm going to want. I'm going to ask for the equation written correctly. I want the replacements, and then I want the words, the description, right? When it says describe, you will always use words. Again, that diploma wording that we always have to know. Okay, another 10 seconds. Okay, Greg, can you write it correctly so everybody's with the right people? Yeah. Okay, so now the y's are with the y's, the x's are with the x's, and this is training you to know the 2 does not belong with the x. Okay? And that's what some of you mistook on the quiz, and it messed you up. Okay, Alex, what were the replacements then? Okay, we're not doing B, so we have lots of room to write over there. In words, what happened? Alyssa? Okay, good job. Okay, and we already did example 2 before, so we're just going to do... Now, if I had f of x equals x plus 2 minus 6, without a graphing calculator, we're going to figure out the domain and range, the y-intercept, and the equation of the asymptotes. Okay, so now you want to write it correctly. Make sure you get the y's with the y's, the x's with the x's. Now, one thing you got to ask, this 4, if that was a 4, a 10, a 20, what does it only affect? Not the x. I'm talking about in the graph. What does it affect? The steepness. That's it. Does it affect the y-intercept? Does it affect the domain and range? No. Okay, so you got to know that. Okay, that's important to know. It just affects the steepness. So it does have effect on a graph, don't get me wrong, but it does not affect the important things that we're looking for. Okay. Okay, so Sienna, how would you write this so the x's with the x's, y's with the y's? Okay. Now, just so you know, this would have been the original graph. Okay. The replacements then, if that happened. Melanie? Okay. So Colton, what happened? So the good thing about the first unit we did is we're going to use it through the entire year. The bad thing about that unit is that we're going to use it through the entire year. It is a bad thing if you don't know the first unit. It is a good thing if you do. Okay? What's the y-intercept of this graph? Like, this is what it used to be. Right at 1. What do you think is going to happen if you moved it down 6 and then 2 left? Okay, so if you moved it down 6 and 2 left, it might look something like this, right? So without a graphing calculator, how am I supposed to find the y-intercept? You'd have to know that point though, right? So you'd have to know, I would go, if I had the graph and I was looking at it, I would go 2 right and 6 up and find that, right? And then see where it would hit, right? Some of you guys might be surprised where it does hit. Say that again. Set x to 0, okay? So you would just go y equals 4 times 0 plus 2 minus 6. Y equals 16 minus 6, which equals 10. So the y-intercept's actually 10. See, that thing's so steep that when you bring it over 2, it hits up that high, right? What do you think the equation of the horizontal asymptote would be? This is another good question. This is all diploma stuff here. Okay, why? Okay, no, it didn't. Where was the horizontal asymptote before I moved it? 0. So it would be minus 6, right? So remember, if the horizontal asymptote was at 0, and I move the asymptote down, I move the whole graph down 6, that asymptote will be at y equals -6. Okay, so not a lot of heavy math today, just kind of knowing this stuff over and over again. So I didn't have any students, I think, ask any questions in the last one. They just got her done. Okay, so you got lots of time. You have half an hour to do a 29-minute assignment.